Let's start by finding the nominal GDP for years 2019 and 2020. Now, if you recall, for nominal GDP of say 2019, we are using the current year's prices, so 2019's prices, along with the quantity of that year as well, 2019, because we're interested in looking at the production amount of that particular year, which is 2019. Same thing with nominal GDP of 2020. You would use the prices of that year, 2020, and the quantity of that year, 2020 as well. So we have three goods in this economy. We have candles, we have hot dogs, and mints. In 2019, candles were priced at $3, and this economy had produced 90 of them. We also had hot dogs at $4 per hot dog, and there were 120 being produced. And for mints, they were priced at $2, and there were 80 being produced. And so sum it all up, and we have the nominal GDP of 2019 being $910. Now we do the same thing but for 2020. In 2020, our price of candles rose to $3.50, and we were also producing more at 100. Hot dogs became cheaper at $3.50. We are producing more hot dogs in 2020. Mints are also slightly more expensive at $2.10. We're producing 100 units of mints. Do the math, and we find out that the nominal GDP of 2020 is 1085. Now let's move on to finding the real GDP. Now, for example, if we're looking at the real GDP of 2019, what's same is that we're still looking at the quantity of 2019 because we're interested in the GDP of 2019. Hence, we're interested in the quantity of goods and services produced in 2019. What's different is that for prices, we're no longer going to use that current year's price, but rather we're going to use the base year's prices. In this question, you're asked to use 2020 as the base year, so we'll be using 2020's prices. For real GDP of 2020, again, we are still interested in the quantity produced in year 2020, but we'll be using the base year's prices, which is still year 2020. So what you should immediately notice here is that for year 2020, your nominal GDP and real GDP are actually exactly the same. And that's because year 2020 is your base year. So year 2020 for nominal GDP is your current year, but it is also your base year for real GDP as well. So even without doing another round of calculation, we are able to see that real GDP for year 2020 is exactly same as your nominal GDP of 2020 at 1085. Again, that's because year 2020 is your base year. On the other hand, things are going to look a little different for the real GDP of 2019. Again, in 2019, we are producing 90 candles. The price is going to be $3.50 because we're using 2019's prices. And same for hot dogs and mints. We're producing 120 units for hot dogs and 80 units for mints, but for prices, we're using 2020's prices. So for hot dogs, that's $3.50. For mints, that's $2.10. Do the math, and that gives us $903 for the real GDP of 2019. Let's find a GDP deflator for both years. To find the GDP deflator, you need to divide your nominal GDP by your real GDP and multiply 100. So what this means is if it's your base year, so if you calculate the GDP deflator for 2020, you'll do that by dividing your nominal GDP of 2020 by real GDP of 2020 by 100. But we also know that for 2020, because that's the base year, your nominal GDP is exactly the same as your real GDP. And so they canceled out, and the resulting GDP deflator for year 2020 is going to be 100. And that's because this is your base year. Now, on the other hand, if we were to calculate the GDP deflator for 2019, we do the same thing. We divide our nominal GDP of 2019 by the real GDP of 2019 and multiply by the 100. If you plug in the numbers, it's 910 over 903 times 100, which gives us 100.8. So just by looking at the GDP deflator of both years, what you should have noticed is that because the GDP deflator for 2019 is greater than that of 2020, prices on average were generally higher in 2019 compared to 2020. That's what the GDP deflator tells you, and this is why the GDP deflator is also an example of a price index. We can also figure out by how much our prices changed between 2019 and 2020 by figuring out the percentage change in the price index, which is your inflation rate. So if you want to figure out the inflation rate of 2020, you look at the difference in the price index between your year of interest and the previous year. Compare it to the previous year, and then you multiply by 100 so you can denote the changes in percentages. In part D, the price index that we're going to use is the GDP deflator. So let's plug in the numbers. In 2020, that was our base year. So our price index was 100. The GDP deflator was 100. In 2019, our GDP deflator was 100.8. Times 100, and that gives us an inflation rate of negative 0.8%, roughly. So that's the percentage change in our overall or aggregate price level measured by the GDP deflator that we found in part C. Now in part E, we're asked to find the cost of market basket for both years 2019 and 2020. And in the question, the market basket is given as 10 candles, 6 hot dogs, and 14 tins of mints. And so we're going to figure out the cost of the market basket. So in other words, to buy the same market basket of these 3 goods, how much money do we need each year? Starting with 2019. In 2019, the price of candles was $3. We need to buy 10 of them. Price of hot dogs was $4. We need to buy 6 of them. Price of mints was $2. We need to buy 14 of them, which gives us the cost of market basket at $82. We'll do the same exercise for year 2020, and the market basket is still the same. We still want to consume 10 candles, 6 hot dogs, and 14 tins of mints. What has changed is the price of these goods. Candles are now $3.50. Hot dogs are $3.50. And mints are $2.10. So it's the price of the goods that have changed, not the market basket. And so to buy the same number of goods in 2020, you need $85.40. Now we'll find the CPI using the cost of market basket. The CPI, or the Consumer Price Index, is calculated using the cost of market baskets. So for example, in 2019, you're looking at the cost of the market basket in 2019 compared to the cost of the market basket in your base year times 100. And same thing for 2020. You're looking at the cost of the market basket in 2020 compared to the cost of market basket in your base year times 100. Now, our base year is still 2020. So what this means is, if you look at the CPI of year 2020, which is your base year, then you're dividing the cost of market basket of 2020 by the cost of market basket in the base year, which is also 2020, which means your CPI of 2020 would also be 100. And this is because, again, your 2020 is your base year. It doesn't matter if you're using the GDP deflator or the CPI. Your base year will always be 100. On the other hand, for the CPI of 2019, we have a cost of market basket in 2019 being $82, while in the base year it's $85.40 times 100, and that gives us the CPI of 96 for 2019. So if we were to compare the two numbers for the CPI, then what we can see is that because the CPI for 2019 is lower than 2020, prices are lower for 2019. Now, by how much? We can use the same inflation rate equation we used in Part D to figure out by what percentage prices have changed over the years. Now, we'll use the same equation as in Part D, but the price index that we'll be using in this case will be the CPI, not the GDP deflator. In 2020, our CPI is 100. In 2019, it's 96. And that gives us an inflation rate of 4.2%. Now let's compare our inflation rate for 2020 that we found in Part D versus Part G. Now, if we compare the inflation rate that we calculated for 2020 in Part D versus Part G, we see that the numbers are quite different. According to Part D, it says that we had a slight deflation, while in Part G, we've had an inflation. Now, this difference comes from the fact that we're using different price indices, GDP deflator versus CPI, which means that we're putting different weights on the different goods that we have. Candles versus hot dogs versus mints. In the case of GDP deflator, we're using the amount of production in the economy. So if we look at the amount produced in, say, 2020, then out of all the goods that we have produced, we have 100 candles, 100 mints, and 150 hot dogs. We see that the price of candles and mints have risen, but the price of hot dogs has fallen. And so in the case of GDP deflator, hot dogs take up roughly 43% of the total goods produced. So we have the fall in the price of hot dogs, being represented more. And that's why we have an inflation rate of negative 0.8% if we use the GDP deflator. On the other hand, the CPI uses market basket, or in other words, how many goods and services do consumers typically consume. So if we look at the market basket, we are consuming a total of 30 units of different goods, and we are consuming 10 candles, 14 mints, and 6 hot dogs. So compared to our representation of hot dogs by 43% in our GDP deflator, in the market basket, hot dogs only take up 20% of the goods that we consume. And so what ends up happening is the fall in prices of hot dogs is not represented as much when you're using the market basket. Instead, the rise in prices in candles and mints end up being more represented in the case of the CPI, which is why we see our inflation rate showing up as higher when we're using the CPI as our price index versus the GDP deflator. Again, this is just coming from the different weights that each good has. If we're using how much is being produced in the case of GDP deflator versus how much is being consumed by a typical consumer when you're using the market basket to calculate our CPI.